Hello, the Darkness344 here. Today, as you can see, I've been building for like 6 hours, 7 hours, I really don't know, without a break or anything, so the recording may probably be pretty dodgy, so yeah, bear with, but this is what I've been building. It's pretty cool, and it's another computer, yeah. This is an 8-bit computer, so double the previous computers that I've been building. So I have the 4-bit computer over here. Just turn down the volume. I have a 4-bit computer over here, which you may think, oh, it's a similar size, but actually that's because of certain components like this display drive that isn't finished yet, but we'll finish that in the tutorial. This computer isn't finished yet. There's still several things we need to do. It'll be very cool when it is finished, because it's a very fast computer. And that computer that I've just built is actually based off of this architecture, so it's basically this but upgraded. So, and without a display. I haven't added a proper numerical display on that one because I can't be bothered to build a binary coded decimal decoder for 3 digits just yet anyway. I would add it if I was building it like a really proper 8-bit one. So the only difference between this and this is that's 8 bits, so double this. Better ALU. It only has 3 bytes of RAM, and these are only nibbles of RAM, but it has 4 of them, whereas that one only has 3 because I didn't want to make it too big. This has 16 lines of code, whereas that one only has 8, because this is more for demos and purposes testing only, where this is for anything. I mean, this one is probably better. Probably faster and better because it has more just functions in general, but this one is 8 bits and it uses my ALU that I showed off in my 50 subscriber special, so it's very cool. And it has 5 functions, this ALU. I could have made it much better to have like a lot more functions, but that would be on a future computer if I did that. I actually have drawn up a design for a better ALU off of this, like, because there are some problems with this ALU. And I've made a better design, because you can't subtract on this. That's a big thing you would want to do, but you can't subtract with this ALU. And it's really easy to fix. It's just like you just have to invert input A and not the outputs. But that's quite easy because I could just have a table saying do the not function on this and also invert input A, which is really simple, very simple to do. So that's that out of the way. So this is the I/O, really simple, plain. It has conditional branching, oh yes, and just a clear RAM, program on off, clock once, and your on off switch. It doesn't work yet because I haven't put all the repeaters in. As you can see, there's all these lines without repeaters. When I put them in, it should work. I mean, like, it only has 8 lines of program, which is really small, but it does have conditional jumping, so and the conditional branching is if the ALU output is 0. Which I haven't built around it, I've built over here. So if the output is 0 and conditional branching is on, it should trigger this. But of course, I've put this in a NOT gate and it should not be in a NOT gate. And of course I haven't wired it up properly yet. So when I do, it should all work properly. So I mean, I should really just go like this, I guess. Because this does... yeah, this does not need to be knotted, this line. And of course I have repeaters and stuff when it's all finished, because I never put repeaters in for some reason. I used to all the time, but now I don't. So, well, I've put some repeaters here, and I know it'll become much slower when I put the repeaters in, but I mean, you know, it's needed. And I also haven't done the RAM fully yet, because I still need to add in the... What have I done here? Whoops. I can say for sure that is not meant to be a thing. I'll just move this real quick. This is the RAM reset, by the way, so 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It should still reach. Let's try. yeah, it still works. Okay, all good. Alright, but so yeah, the instructions there. I'm getting sidetracked now. The instructions. You have read ALU, which I should have put over there, but I mean I forgot that I needed it because I'm using latches for my ALU, so there's always a constant output, so you need a read ALU command. I have the RAM address, so you can address to 3 cells of RAM, and I know I could have done 4 cells, but I will. You have the RAM address bus, so you can read and write. Then you have your main data bus, which yeah goes 8 bits, goes up to 128. I'm pretty happy with this computer, the way it turned out so far. If it works anyway, I think it will work because it's almost the exact same architect. I think it's the exact same architecture. So the way the data flows is the exact same as the way the data flows on that computer over there. Which this way of data flow is very, very efficient, but it does mean that you can only really operate one thing at a time. You can't have the ALU and numbers being input. Like, you can't have an ALU output and also numbers being input at the same time, or the data corrupts and stuff. So I mean, it's kind of weird. But I mean, the good thing is that you can do simple addition without the ALU by, say you read a number from RAM, but you just wanted to add one binary thing to it. So say it's this, and if you wanted to add that to it, then it's kind of hard. But if you just wanted to add another place value, you could just go like that. And of course your RAM would be reading here, and then it would mix with that, and it would all mix on the same bus and basically add the extra bit. But yeah, that's just a cool thing you can do with just having one big bus that's shared. So the way it works is it comes out from the program memory, goes into the ALU, and also, into the ALU registers, and also into the RAM. And you can trigger the registers, say you could either trigger ALU register A or ALU register B. So you can trigger which one you want to input. So either input 1 or input 2, basically. And you can also save to which RAM cell you want, and you can also read from the RAM cell and it will output on the main data line. These are single read only because you can't read more than one RAM cell at a time, or else it corrupts the data. You can input your RAM, the data from the RAM back into the ALU. It goes, basically, when you read the RAM, it basically goes back round into the program memory. Program memory? Yeah, sure. It basically goes back into the program and comes out here. So it almost says it inputs, basically. The ALU has 5 functions. You can not the number. You can only do it with one number, or else it breaks. You can not the number. I think you can do it on A or B. I think it works for both. You can not the number, you can AND the number, you can XOR the number, you can OR the number. Not and or. Oh yes, and you can also add the number. Like, you can't subtract at the moment, but that's just a stupid design flaw that I just haven't put it in. So I mean, it's quite easy to put in. I may design an AL. I already said I had a design in that basically does a lot more functions. Like, it also does like NOR, XNOR, and all these cool stuff. And then the best bit about this computer is it has conditional branching, which I think I've talked about in my last video. Well, one of my last videos, I don't know. And yeah, I've already explained it, but it's pretty cool because it means you can do some clever stuff. Not sure if you can really do clever stuff without subtract, but I bet you can probably write a subtract algorithm using the not feature. So, like, what you can do, you can save, you can input number A. You say input number to A, and then not it, then save to RAM 1, then you read RAM 1 and you input to ALU A again, so it's basically the knotted variant, and so you input it, and then you just input, and then you say write to ALU register B number 2, and then you can read from the answer, and that is a basic subtract algorithm. And you probably have enough lines to do it and also do a conditional branching. So you put in your first number here, you have your subtract algorithm that runs until the number 0 and then jumps to your last line where it says it's finished. And that is basic conditional branching right there. And I know it only has 8 lines, like I could have easily expanded it to have more. I might actually do that in the future because I mean it's not too hard. I don't think it changes much. All it does is add an extra 8 lines, which is always very useful, and it doesn't lengthen the program too long. And I haven't done a proper clock yet, like this is just the basic clock at the moment. I'm not sure if this is too fast for it. Wait, what? Excuse me. Oh, that's the program off. So here's the clock. I'm not sure if it's too fast, but I mean, so you have your clock cycle. I'm not sure if it's too fast, but I think it's should be alright. And of course you can adjust it in the front panel, which is a cool feature. And of course you can adjust the back one too, but I mean, meh, who needs to adjust that, you know? So yeah, these are the functions, by the way. Instead of I've done the same thing as I've done on this one, where, actually no I haven't. My very first computer, AX344 version 1.0, I actually had the functions, right, as actual individual program lines. And that's a problem, as it took up a lot of program. Like you had to make the program massive, and it just took up a lot of space. It was so inefficient, the design. I mean, this design's much better, this architecture. And this is almost based off the first version, just with a few modifications, such as instead of the display being pulled off the RAM, it's now pulled off the main data line. So you can either pull it off the RAM or the main data line. And that is very useful, because the old version, it means you couldn't just write a number and say display. You had to read it from RAM. So you had to write it to RAM first, then read it, and then ask it to display. And of course this computer does not have a display because I can't be bothered and it will take too long. It just has a binary display here, which I could make nicer, but oh well. So if I go up here, you may be able to see a similar architecture to my one over there, where the data goes through the program, down to the ALU, and also to the RAM. The ALU also goes back. I've done that wrong, haven't I? Ooh. The ALU goes straight to RAM. But I mean, that doesn't matter because the ALU will only go to RAM anyway. So that's... I mean, it's not a bug. It's an intentional feature because the ALU won't... You can't really do anything with the ALU number. You can't input it straight back to the ALU. You have to save it to RAM first, so it just saves to RAM. So yeah, that's an intentional bug. Then, yeah, so it basically just goes round and round. And the ALU can be saved to RAM, or not really much else, and it can go back round, back into the ALU if you want. That's pretty much what it does, and all it does. It's the same as this one over here, except this one has a display and more RAM. And as you can see, it's kind of harder to see on this one, but it goes through the program, over here, into the ALU, and also into the RAM, and the ALU goes all the way round back into the RAM. I mean, I could have made the ALU go straight to the RAM, but that would have been harder, as I'd have to loop it around like that, and this is just easier. So yeah, it's a very similar architecture, but it is double the processing power and a better ALU. This ALU took me a very long time to design, by the way. I did it in my 50 subscriber special. I said that already, but oh well. And
because I had to do it all. I wanted to do it all in this. It's a tileable ALU, infinitely tileable, and I wanted it to be in a 4-block width space, not 5 blocks, only 4 blocks, and that was very hard to do, to include all the main features that I wanted. There are still some missing features that I would want in this ALU, like shift left and shift right. Shift left is easy as having a module in front to say, if shift left command is on, put input A to register A and also register B, because that's basically shifting left. You add the number to itself and it shifts it left because it's timesing by 2 technically. Shift right is dividing by 2. That's a bit harder. I'd actually probably just build a module on top of it. Say if it shifts right, it just goes into this module and it shifts it right and drops the bit. I mean, this conditional branching only uses if the ALU output is 0. It does not use the extra bit. I mean, I just dropped the extra bit. Like, where is it? It would come out here. This is the extra bit, so it's 8 bits, and the 9th bit is just dropped. It's not used in this computer, which I mean is lacking. But I mean, with an ALU like this, yeah, there's not much point having a 9th bit. So yeah, just stick with it, I guess. This computer is not done yet, so there will be no world download. Of course, when I'm going to finish this before I finish that, most likely. But once this computer, this tutorial series is finished, I'll include a world download of this computer. But the world download will also include this computer because it's this world, by the way. This is my redstone world, so yeah. You can find redstone stuff. Not really much stuff because it's a fairly new world, but I mean, that's about all the stuff that's in the world. And some of it doesn't work, by the way, so like trying to find something that actually doesn't work, like this doesn't work because those are knotted and they're not meant to be knotted, and it's missing some repeaters because I never like putting in repeaters. This was actually the first design for my ALU, what am I talking about? My first computer, so AX344 version 1. As you can see, it's a very similar architecture. I mean, programs. I think as you see, add, subtract, and, or I should have just done a binary decoder. You can also find weird other things like this half-broken piston door. Oh yes. RAM. Don't even get me started on this. Some comparator stuff. I never really like comparators, experimenting with comparators. They're pretty cool, but I mean, I just find them annoying to work with because you have to keep the 16 signal length and stuff. And I mean, it's great for hexadecimal, but it's just annoying in general. More stuff, just random stuff. But that computer is pretty cool, if I don't say myself. So, I mean, 8-bit computer in development. When it's finished, I'll release a proper video. This is just like an FYI, FYI. I don't even know what that means, to be honest, so I shouldn't be using the word, abbreviation even. But when this is fully finished, I might even add some more program memory. I probably will, because 8 lines is not a lot. But I mean, for an ALU like this, the ALU is still limited. That's the problem. So, because I've been learning this topic so fast, I've been learning redstone computing so fast, each time I make something, make a design, like this ALU for instance, I learn more stuff, and I'm like, oh, this design becomes really outdated because it lacks certain features. It has stupid features like this knot feature. You shouldn't have the knot there. You should have the knot at the beginning of the program, at the very end of the ALU even. I shouldn't have said program. So the knot feature is kind of useless in this ALU. And of course it should have had subtract. And of course, when I do upgrade this, I'm going to keep this exact same design. The only thing that I'm going to change is have a subtract module and a shift right and shift left module, as well as a knot feature at the very end. I'll just move that not feature to over at the very end. This not feature will actually become part of the subtract module because it's easier just to do it like that. So yeah, I hope you like this rather weird showcase of this unfinished computer that I'm working on. And yes, the entire thing has taken me something like 6 hours so far. I've been doing it instead of schoolwork. I know, bad. Oh well. Yeah. Okay, I'm not sure what to say now. But yeah, if you liked this computer, I mean, the finished version will come out in a world download later when that is done, or even when I showcase this off and stuff. So it could be cool to experiment with, I guess. It's not the best 8-bit computer in the world, but I mean, it's more based on learning stuff because it's a very simple one with some fairly decent stuff like conditional branching. I know it's just a rubbish conditional branching, but I mean, it's still a simple 8-bit computer just to get you started. So yeah, if you like this video, please like and subscribe. And yeah, thanks for watching, and I am out.